Reality hangs by a quantum thread, a single misstep, and everything ends. Our universe exists in a state of suspended catastrophe according to the standard model. We inhabit a false vacuum, a metastable state, balanced on the knife edge of existence. The Higgs Boson mass 12518 GeV. This number determines everything. A few GeV lower, our vacuum would be stable. A few higher, unstable. Instead, we hover precariously in the metastable zone. This false vacuum could quantum tunnel into a lower energy, true vacuum at any moment. The decay mechanism is quantum tunneling, spontan nucleation of bubbles, of true vacuum bubbles that expand at light speed, rewriting the laws of physics as they go. It is not destruction. It is replacement. A silent, instantaneous rewriting of everything. Yet cosmic doom is delayed by an incomprehensible time scale. The decay rate suggests a lifetime exceeding 100 years. Our universe's current age, 13.8 billion years, is but an infinitesimal blink, a flicker in the cosmic darkness. But in 2024, humanity achieved a breakthrough. The first experimental evidence of bubble nucleation mimicking false vacuum decay in supercooled atomic vapor. We witnessed quantum fluctuations triggering bubble formation, a laboratory analog for the most terrifying end-of-universe scenario. We now have our first glimpse of how that end might unfold. The universe's ultimate fate is written in the value of the Higgs field. And we are balanced on a quantum knife edge, where the fundamental stability of reality itself depends on fragile quantum probabilities. We exist in a false vacuum metastable, waiting. The question is not if it will decay, but when. Imagine our universe as a mountain lake, supercooled beyond its freezing point. This is the false vacuum, a state of precarious calm that could persist for 10 years, an eternity by any measure. Yet within this apparent stability, physics whispers a terrifying secret. We exist on borrowed time. When the quantum tremor finally comes, it doesn't arrive gradually. It explodes outward at over 0.90 FAFK, approaching the universal speed limit itself. Not propelled by matter, but by pure energy release, a wall of true vacuum that rewrites reality as it expands. This conversion is governed by a precise threshold. RC equals 3 sigma over epsilon. Surface tension versus energy density difference cross that critical radius, and the transformation becomes unstoppable. But this is an abstract speculation. Our own cosmos was born through exactly such violence in its first violent moments. The universe underwent multiple catastrophic phase transitions. First, the gut transition at 10x16 GeV, then the electroweak transition at 100 GeV when the cosmos was just 10 to 11 seconds old. Finally, the QCD transition at 150 MeV, 10 at 5 seconds after creation. These weren't gentle shifts, they were explosive first-order transitions where bubbles of new physics collided and merged. For matter to dominate over antimatter, The electroweak transition must be violently first order. Yet with a 105 GeV Higgs boson, our standard model shows only a gentle crossover. This contradiction haunts modern physics, revealing gaps in our understanding. These expanding bubble walls, racing at near light speed, generated ripples in space-time itself. A stochastic gravitational wave that permeates the cosmos. Today, observatories like LIGO, Virgo, and LISO search for that faint hum, a relic from the universe's violent youth. Remarkably, the gravitational effect is nearly zero. Einstein's equations maintain perfect balance. The positive energy of the expanding wall canceled by negative energy density inside a cosmic accounting that preserves the fabric of reality. The mechanism is the Coleman DeLucia instanton, quantum tunneling on a cosmic scale, a statistical fluctuation that pierces the energy barrier, nucleating a bubble of true vacuum in the false. And in laboratories today, physicists recreate this drama. Using supercooled Bose-Einstein condensates, they watch quantum bubbles nucleate and expand, a microscopic echo of potential cosmic catastrophe. We stand on reality's knife edge between statistical eternity, an instantaneous transferment between wonder at the physics and dread at the implications. Our universe balanced on quantum uncertainty, with cosmic stakes. A bubble expanding faster than anything but light, a wall rewriting the laws of physics as it passes. This isn't just theoretical possibility. It's the violent history of our own existence, and potentially our future. There is a ghost in the mathematics of our universe, a terrifying possibility lurking in the equations of quantum mechanics. In 1977, the physicist Sidney Coleman gave it a name. In a form his work suggested our entire cosmos exists on a knife's edge, that we inhabit what he called a false vacuum, a state of energy that feels stable, but is not the final ground state of reality. It is a shallow resting place in a vast landscape of cosmic potential. And somewhere else, there is a deeper valley, a state of absolute stability, the true vacuum. To get there, our universe would have to climb an impossible hill. Except Coleman realized the cosmos doesn't have to climb. It can cheat. He applied the bizarre principles of quantum tunneling to reality itself. The idea that a particle can simply appear on the other side of a barrier without ever crossing the space between. What if a tiny patch of our universe did just that? This is the theory of bubble nucleation, a spontaneous, unpredictable event where a microscopic bubble of true vacuum flashes into existence. Inside this bubble, the properties of matter and energy are shattered. The very laws of physics that govern our existence are rewritten into something alien. and the bubble grows. It expands outward in all directions at the speed of light. A silent, unstoppable sphere of death. It doesn't burn or crush. It simply replaces deleting everything it touches from reality. Stars, galaxies, life, wiped clean by a fundamental change in the rules. We would never see the end coming, because it would already be here. A mathematically elegant doom, buried in the heart of Coleman's 1977 revelation.
The discovery should have been a triumph, a final answer. Instead, it was the beginning of a cosmic crisis. We measured it. The 125 Joule, the Higgs Boson. But this specific number, it's not just a measurement. It's a cosmic tipping point. The precise boundary between two possible fates for our universe. Metastability and catastrophic vacuum decay. According to quantum field theory fundamentals, the Higgs field permeates all of space-time. It's the trembling surface that gives mass to everything. Every particle, every atom, every star. But calculations reveal a terrifying truth that this measured mass, our cosmic vacuum, is not the true ground state of reality. It's merely a local minimum in a cosmic energy landscape. A precarious valley in which our entire universe is trapped. The Standard Model's apparent success at lower energies. It's a mask. A brilliant facade that hides a profound instability lurking in the mathematics. The Higgs potential become unstable at energies we can barely comprehend. Our reality is balanced on a razor's edge. A quantum tunneling event could pierce this fragile equilibrium, triggering a bubble of true vacuum. It would expand at nearly light speed, rewriting the fundamental laws of physics across the observable universe. It is not destruction. It is replacement. The very fabric of space-time would be rewoven as it passes. A silent, instantaneous rewriting of everything matter, energy, forces, all would collapse into new forms. Forms we cannot predict, cannot comprehend. The Standard Model is incomplete, cracked at its energetic foundations. The Higgs mass measurement forces us to confront an existential question. Does new physics exist to stabilize our reality? Supersymmetry, extra dimensions, undiscovered particles waiting in the shadows? Or do we truly inhabit a universe poised for cosmic annihilation? The answer lies in that precise number that should have brought closure. Instead, it shattered our certainty, revealing that our entire understanding of particle physics is built on shifting sands. The universe we see, the laws we know, they may be temporary, an illusion of stability in an unstable cosmos. The Higgs boson didn't complete the Standard Model. It exposed its fatal flaw. And now we must ask, what holds back the tide of true vacuum? What prevents our reality from collapsing into something else? The clock is ticking, not in human time, but in cosmic time, on scales beyond our imagination. We have measured the mass. We have seen the precipice, and we stand at the edge, looking into the abyss, wondering if new physics will catch us, or if we're about to fall. surface of reality lies not one unified fabric, but a tapestry of fields, multiple quantum fields woven together through Lagrange interaction terms, Selm's Yukawa couplings. They talk, they exchange forces, we capture their conversations in Feynman diagrams, complex scribbles that map their intricate dance. But below this dance, a deeper truth emerges. Empty space is not empty. The quantum vacuum is a seething ocean, a chaos of vacuum energy fluctuations, zero-point energies of countless quantum harmonic oscillators, vibrating at the very boundary of existence. Sum these fluctuations, extrapolate them to the Planck scale. Jeeve, the mathematics gives us a staggering prediction. Vacuum energy, approximately an unimaginable energy packed into every cubic centimeter of nothingness. Then look at our universe, observe cosmic expansion. The cosmological constant, what we actually measure, is a whisper compared to the predicted roar, the discrepancy. Not tenfold, not a millionfold, but orders of magnitude, the largest mismatch between theory and reality in human history. This vacuum energy defines not just density, but position. We exist in a potential energy landscape, a multi-dimensional cosmic terrain of valleys and mountains. The valleys are vacuum states, stable configurations of reality. Our universe does not sit in the deepest valley, the true vacuum, the global minimum. It is perched in a false vacuum, a metastable local minimum. We are stranded on a ledge, separated from the abyss below by a fragile quantum barrier. But quantum mechanics offers no permanent refuge, quantum tunneling. The universe could simply pierce the barrier. A spontaneous fluctuation in reality would tunnel to its true ground state. This is not mere destruction, it is replacement. The very laws of physics would be rewritten as a bubble of true vacuum expands at nearly light speed, erasing everything in its path. This landscape is shaped by the fields themselves. The Higgs field gives us the model. Its Mexican hat potential, where symmetry breaking rolls the field from an unstable peak into a stable ring, giving mass to the universe. But other fields, other interactions, they create competing minima saddle points, a treacherous geography. Our current configuration is a balance, a miracle, or a ticking clock. The vacuum energy is unnervingly small, either miraculously fine-tuned to one part in, or it signals a deeper cancellation we cannot see. The pillars of reality rest on this. The dance of interacting quantum fields, the suppressed scream of vacuum energy, and the precarious valley we call home.
Emptiness is an illusion shattered by quantum mechanics. The quantum vacuum, what we once called nothing, is not empty. It seethes. It boils with hidden energy. This is zero-point energy, the lowest possible state of a quantum system. But lowest does not mean zero. It means a baseline of existence, a fundamental churning. At the heart of this paradox lies the Heisenberg uncertainty principle, energy and time. Locked in a quantum dance of impossibility, you cannot know both simultaneously with perfect precision. There is always uncertainty. This uncertainty grants reality a loophole, a temporary suspension of the rules. Particles can borrow energy from the void itself, but only for the briefest moments. The more energy borrowed, the shorter the existence must be, a delicate balance maintained by the mathematics of the universe.
These are virtual particles, fleeting quantum fluctuations. They pierce reality's surface, then vanish. Particle-antiparticle pairs erupt from nothing, dance for femtoseconds, and annihilate before they can be caught. They live on borrowed time, borrowed energy, existing in the gray zone between being and non-being. But how do we know they're real? The evidence lurks in the subtle signatures they leave behind. The Casimir effect, two metal plates brought infinitesimally close together between them. Only certain wavelengths of virtual particles can exist outside the full spectrum. This imbalance creates pressure. The plates are pushed together by the weight of missing possibilities, measurable proof of what we cannot directly observe. The Lamb shift, a tiny energy difference in hydrogen atoms. Virtual particles shift electron orbits ever so slightly, a whisper of the void's activity echoing through atomic structure. Not a theory, but a measured fact. These are not theoretical curiosities, they are the fingerprints of the quantum foam, the signature of a vacuum that is never truly empty. In quantum field theory, this is how reality operates at its most fundamental level. Fields permeate all of space. Their ground state is this seething vacuum. Virtual photons mediate the electromagnetic force between charged particles, carrying messages across the void. Every push, every pull, emerges from this sea of temporary existence. Think about that. What we perceive as empty space is a violent churning ocean, particles appearing, annihilating reality itself with every passing moment. The ground beneath our feet, the air we breathe, all resting on this foundation of perpetual creation and destruction. This is the quantum vacuum, not absence, but infinite potential. Not nothing, but everything waiting to happen. The zero point from which all existence emerges. The void that is never truly empty, because emptiness itself is a myth. We stand on the shore of an ocean we cannot see, feeling only the faintest ripples of its true depths. The quantum vacuum, when nothing contains everything.
Deep beneath the earth, humanity's greatest machine awakens. The Large Hadron Collider in Run 3. It hurls protons together at 13.6 teri-electron-volts, energies that existed microseconds after the Big Bang itself. We are recreating the birth of reality. Within the ATL's detector's colossal embrace, we hunt ghost particles that exist for less than a trillionth of a second. The Higgs Boson decaying to 2 photons, 76 femtobonds plus or minus 14, a statistical whisper against the cosmic roar. Even more elusive, its decay to 4 leptons at 2.80 femtobonds with an uncertainty of just 0.74. These numbers represent the edge of human perception. The faintest tremors in the fabric of space-time, measured with surgical precision. 125 GeV. This is the mass that sculpts our universe. The exact value that gives particles their substance, their identity. With these measurements, we have confirmed the Standard Model's most profound prediction. We have captured the mechanism of existence itself. But in this triumph of measurement, something lurks, a secret buried in the numbers. A truth more unsettling than any we anticipated. The vacuum metastability bound reveals what these precise measurements imply: the Higgs field. That invisible ocean that fills every cubic centimeter of our universe, the field that gives everything its mass, exists in a state of quantum anxiety. It does not occupy the true ground state. It sits in a local minimum, a shallow valley surrounded by mountains that hide a deeper abyss. At energies between 10 to the 9th and 10 to the 11th giddy electron volts, the barrier could be pierced. A quantum fluctuation, a random shudder in the vacuum could trigger the unthinkable. A phase transition that would rewrite the laws of physics. It begins as a microscopic bubble. Then it expands at light speed, consuming space as it grows. This is not destruction in the conventional sense, it is replacement. The very fabric of reality would be rewoven. The constants that govern our universe would change: matter, energy, time itself, all would cease to exist in any form we recognize. Our most precise measurements have given us both mastery and dread. The experiments that validated our understanding of reality have simultaneously revealed its fundamental instability. We have looked into the heart of existence and seen its temporary nature. We exist on borrowed time, in a state of grace, an island of stability in a cosmic sea of potential oblivion. The numbers are exact. The mathematics is flawless. The conclusion is inescapable. Our universe is not stable. It is metastable. For now, we persist.
Space delivers what engineering cannot reach, while humanity builds its mightiest machines. Nature operates at scales that shatter comprehension. Deep from the cosmic void, ultra-high energy cosmic rays carry forces beyond imagination. Subatomic projectiles piercing the darkness at velocities approaching light itself. The most extreme among them, the oh my god particle, carried approximately 3 times 10 to the 20th electron volts. When these cosmic bullets strike Earth's atmosphere, they unleash collisions of 700 to 750 teraelectron volts in the center of mass frame. 50 times more powerful than the greatest collisions achieved by the Large Hadron Collider. These are not merely impacts. They are natural laboratories. Earth's most energetic particle accelerators, probing physics regimes we cannot access, a frontier where nature's forces far exceed human engineering. But here emerges a profound mystery. According to fundamental physics, there exists a cosmic horizon. The Greisen-Zatsepin-Kuzmin limit, cosmic protons with energies above 5 times 10 to the 19th electron volt should interact with the cosmic microwave background, losing energy until they fall below this threshold. Over distances of 50 megaparsecs, approximately 160 million light years, these particles should cease to exist. Yet they arrive particles that should not be, energies that should have been drained. A violation of the fundamental boundary. How is this possible? Either our understanding of particle propagation across cosmic distance is incomplete, or nature possesses acceleration mechanisms far more powerful than predicted hidden forces in our cosmic neighborhood capable of launching projectiles that defy conventional physics. And there is a deeper implication. These ultra-relativistic impacts approach energies where the very stability of reality becomes precarious. The Higgs field exists in a metastable state, a local minimum rather than absolute stability. The instability scale hovers around 10 to the 10th to 10 to the 11th gigaelectron volts. While these cosmic ray energies approach this range, they remain orders of magnitude below what would trigger catastrophic vacuum decay. Yet they probe the boundaries, the fragile limits where our universe's fundamental stability could potentially be challenged. This is not destruction. It is replacement. The very fabric of space rewoven as it passes. A silent, instant rewriting of everything. We stand at the edge of understanding, gazing at particles that should not exist. Energies that should have vanished in a vacuum that remains precariously stable. Either our models are incomplete or the universe holds secrets more profound than we dare imagine. Natural accelerators operating at scales that dwarf human achievement. Launching cosmic messengers that challenge the very foundations of physics.
They shattered the barrier not with force, but with probability. In 1981, Gerd Binning and Heinrich Rohrer pierced the classical veil with a scanning tunneling microscope. They revealed atomic landscapes, but to do this, they exploited a quantum cheat: electrons leaking through nothingness, a vacuum gap of just 4 to 7 angstroms, a ghost current flowing where no current should be, picoampere to nanoampere whispers. Each electron's presence decreasing exponentially, an order of magnitude lost for every single angstrom of void. For this, they earned the 1986 Nobel Prize in Physics. Not for seeing atoms, for touching the impossible. This was no mere microscopic anomaly. The quantum cheat scaled. It grew in 2025. John Clark, Michel Dvorak, and John Martinis revealed macroscopic defiance, their Nobel-winning work. A superconducting circuit cooled to millikelvin temperatures. A Josephson junction became a portal, trillions of Cooper-paired electrons tunneling as one. A collective escape from a metastable state, temperature-independent probability, a macroscopic object behaving as a single quantum entity, an artificial atom, born from engineered control. But the violation deepens. Time itself warps. Rubidium atoms approach a barrier. The Hartman effect takes hold. They spend only 0.61 milliseconds on average within the forbidden zone. They appear to cross faster than light could traverse the same distance, a superluminal illusion, a paradox that respects causality while mocking our intuition. Elsewhere, in the deep cold of the University of Innsbruck, patience reveals quantum slowness. Deuterium ions collide, and collide again. One reaction emerges per 10 to the 11th collisions, a successful tunnel event every 15 minutes, the slowest charged particle reaction ever recorded, a testament to probability's cruel arithmetic. These are not separate phenomena. They are facets of a single lurking reality, from the atomic intimacy of STM to the engineered coherence of superconducting circuits, from temporal paradoxes to glacial reactions. This is quantum field behavior made manifest, a fundamental rewriting of what is possible. The barrier is not a wall, it is a veil.
and everything can pierce it, given enough time, or no time at all. The future of computation, of sensing, of reality itself hinges on this simple, terrifying truth: the universe permits shortcuts through impossibility. In the quantum foam, a bubble forms a microscopic sphere of true vacuum, lurking within the false vacuum. Its boundary, an infinitely thin domain wall, a razor-thin membrane separating two realities. Its fate hangs on a razor's edge, the critical radius. RC equals 3 sigma divided by epsilon sigma. The wall's surface tension epsilon. The density difference between vacuous smaller bubbles collapse. Crushed by surface tension, larger ones pierce the threshold. And then they expand. If it surpasses this critical point, the bubble wall accelerates outward, approaching light speed. It is not destruction. It is replacement. The very fabric of space is rewoven as it passes. The wall converts false vacuum energy into a particle cascade, Higgs bosons, photons, neutrinos, a wave of rewriting that sweeps across the cosmos. Inside, space-time warps. The interior becomes anti-de Sitter space-time. A region of negative energy density, geometry curves inward, fundamental physics shatters, particle masses shift, atomic bonds dissolve, the laws of physics rewrite themselves. This catastrophic expansion is described by the Coleman-DeLucia instant and modeled through the thin wall approximation. A relativistic runaway with no return, yet a fragile equilibrium exists, this grabolization. The bubble's total energy must balance to zero. Interior negative energy offset precisely by the wall's kinetic energy. This delicate balance could suppress decay for small epsilon values. In laboratories on Earth, we glimpse these dynamics. Quantum annealers with 5564 qubits replicate the nucleation process. Supercooled gases, chilled below 1 microkelvin, mirror the phase transition, experimental analogs confirming the theoretical framework. A cosmic catastrophe simulated in controlled environments. Despite the terrifying physics, the universe exhibits extreme stability. Vacuum decay occurs just once per cubic gigaparsec. Every 10 to the 794 years, a timescale so vast it defies comprehension. Yet this cosmic stability hinges on precise values. Sigma and epsilon quantities whose exact magnitudes remain unknown. The ultimate fate of reality. All that we know, all that we are, balanced on a knife's edge.
For millennia, we built our science on a foundation of constants. The speed of light, Planck's constant, Newton's gravitational constant, fixed numbers, carved into the fabric of reality. But what if that foundation is cracking? Evidence now pierces this certainty, the fine structure constant, a The number governing electromagnetism shows measurable anisotropy across the cosmos. It varies with direction. It varies with time. This is not a measurement error. It is a signal that our constants are not constant. This hints at something deeper. A fifth force, perhaps a polarized physical vacuum shaped by 5 fundamental interactions. Our laws of physics may be contingent, determined by the vacuum state our universe happens to occupy. And our vacuum may be a trap. The Higgs field, the entity that gives particles mass, sits in a false vacuum, a precarious higher energy state. It is perched on a quantum hill, separated from true vacuum by a fragile barrier. A single quantum fluctuation could nucleate a bubble of true vacuum. This bubble would expand at light speed, rewriting particle masses as it propagates, erasing all matter in its path. This is false vacuum decay. The universe could cease to exist at any moment. But the terror deepens. Vacuum itself may not be empty. Space could be a polarized medium. In this view, the speed of light is not a fundamental limit, but an electrodynamic constant. Einstein's coupling constant runs with energy density, defining alternative vacuum states where gravity vanishes. In unimodular gravity, vacuum energy doesn't gravitate at all. Our cosmological constant emerges not as a fundamental parameter, but as an integration constant. These revelations shatter cosmology. Modified gravity introduces a varying sheaves. The Friedmann equation gains logarithmic terms. This resolves the Hubble tension. The mismatch in cosmic expansion rates. Energy density scales inversely with cosmic age. Vacuum energy density defies quantum predictions by a factor of 10^20. Particle physics is rewritten. The QCD scale, the QCD, the Higgs vev. These parameters vary relative to the Planck mass, affecting nucleosynthesis, altering the very building blocks of matter. Our universe may be an eigenstate, one possibility among infinite vacuum states in the multiverse. The laws we observe are not universal. They are local, contingent, terrifyingly mutable. The ground beneath us is not solid. It is a thin crust over infinite emptiness. And that emptiness is alive with possibilities, most of which should erase us. The ground beneath us is not solid. It is a thin crust over infinite emptiness. And that emptiness is alive with possibilities, most of which should erase us.
Reality is more fragile than we dare imagine. Every atom, every molecule, every chemical bond, all are elaborate constructs built on a single invisible foundation, the Higgs field. This quantum ocean that permeates all of space gives particles their mass, including the electrons that orbit atomic nuclei. This stability is an illusion, a metastable state. What physicists call a false vacuum. We are balanced precariously in this shallow basin of energy, unaware of the deeper well lurking just beneath our feet. At any moment, a quantum fluctuation could trigger the ultimate collapse. A single droplet falling into that deeper abyss, nucleating a bubble of true vacuum. This bubble would expand at nearly the speed of light, a silent, unstoppable wave rewriting physics itself. As the bubble passes through space, the Higgs field settles to a new value. And everything changes. Electrons whose mass originates from their interaction with this very field would transform instantly.
They might become massless or gain immense weight. The electromagnetic force that binds them to atomic nuclei would surge or collapse. Chemical bonds, those precise connections holding molecules together, would simply cease to exist. Not broken, not torn, they would be unmade, the delicate dance between electrons and protons, calibrated to perfection over billions of years, would become meaningless. The Heisenberg uncertainty principle, which defines the probability clouds where electrons reside, would rewrite its rules. Atoms would not merely fly apart. They would be reconstituted under alien physics. The very concept of matter would be redefined. This is not theoretical fantasy. In laboratories, we have watched this apocalypse unfold in miniature cold atom experiments using supercooled bosonic gases at temperatures below. Simulate vacuum decay. We seed a tiny bubble of decay in the center of an ultra-cold cloud and watch as it consumes everything in its path. An irreversible, all-consuming transformation. The atoms in those experiments tell us a chilling truth. Our chemistry, our biology, our existence itself, all are contingent on a single field remaining in its current state. We are not just living in the universe. We are hostages to its stability.
Emptiness is an illusion, a dangerous deception. What we perceive as void seeds with hidden activity, quantum fluctuations crackle in the dark. Virtual particles that flicker into existence from nothing, then vanish back into nothingness. This is the quantum vacuum. Not empty, but pregnant with possibility. Researchers at Rice University have shattered this illusion of nothingness. They have engineered a new reality using a chiral cavity design constructed from indium antimonide operating with surprisingly low magnetic fields. They have created a new vacuum, a region where the quantum fluctuations themselves are reshaped, controlled, amplified. The cavity twists space into a spiral geometry. It selectively enhances vacuum fluctuations for circularly polarized light. Left and right become fundamentally different. The rules of existence rewrite themselves. Place graphene within this modified vacuum. Watch what happens. The material undergoes a metamorphosis. A transformation that defies conventional physics. Graphene begins as a zero-gap semi-metal. A perfect conductor with no barrier to electron flow. But in this engineered emptiness, it becomes something else entirely. A topological insulator emerges. Electron motion slows to a crawl. Photon propagation shifts. The very behavior of light warps. This is vacuum polarization in action. Mediated by virtual electron-positron pairs, ghostly particles that exist only in the quantum foam. They modify both the permittivity and permeability of empty space itself. The electromagnetic force changes. Its strength reshapes. Photon behavior rewrites itself at the fundamental level. Opacity shifts. Light transmission reduces. But this is not ordinary absorption. Not scattering by matter. This is the vacuum itself resisting. Pushing back. Because we have modified its electromagnetic properties, engineered its nothingness. The vacuum is no longer passive. It has become an active medium, a participant in the dance of reality. By controlling the quantum vacuum, we gain the ability to manipulate fundamental forces, to modify materials from the outside, and all without touching the matter directly, simply by redesigning the empty space around it. We stand at the edge of a new frontier, where emptiness becomes a tool, where the void itself becomes something we can shape, sculpt, control. The implications are profound. Imagine materials whose properties change not because we alter their chemistry, but because we redesign the nothingness surrounding them. Imagine light that slows, bends, stops, not because of glass or crystal, but because of engineered emptiness. The vacuum whispers secrets, and we are finally learning to listen, to understand, to command. This is the true power of quantum engineering. Not building structures in space, but building space itself, creating new vacuums, new realities where the rules of physics are not fixed but fluid, where emptiness is not absence, but potential. The void is no longer nothing. It is everything, the substrate of reality itself. And we are learning to write upon its blank canvas.
What if everything we know, every galaxy, every star, every atom, is just a single note in an infinite symphony? A mere bubble in a frothing cosmic ocean, destined to pop and be forgotten. This vision emerges from a process called eternal inflation, conceived by physicist Andre Linde. It suggests that the explosive birth of our universe never truly ended. Instead, quantum fluctuations keep inflation going eternally in some regions, spawning endless new universes like bubbles in champagne foam. Each bubble universe carries its own unique set of physical laws. In some, light might not exist. In others, fundamental particles could be subtly different or absent entirely. Our universe is just one lucky outcome among infinite possibilities. These bubble universes rarely interact. The exponential expansion of space-vast distances between them. But when they do collide, they leave scars, cosmic bruises imprinted on the oldest light in our universe. The cosmic microwave background. Scientists have searched for these scars. The Wilkinson microwave anisotropy probe, ULM-HEB, scanned the heavens, identifying 4 potential collision regions. But the evidence remained inconclusive. It did not warrant revision of the standard cosmological model. Then came Planck. A more sensitive eye on the cosmos, it provided even more detailed maps of the CMB. And it found no definitive evidence of bubble collisions, yet it confirmed intriguing anomalies, cold spots, hemispherical asymmetries that deviate from the standard LCDM model at roughly 2.7 sigma significance. The scientific status remains precarious. While cosmic inflation is widely accepted, the multiverse extension remains speculative. Critics note the absence of direct empirical evidence. It violates Occam's razor. But if confirmed, through future CMB observations or quantum experiments, the multiverse would represent the most shocking expansion of reality.
Our universe's apparent fine-tuning for life would be no miracle, just statistical inevitability in an infinite ensemble. Every conceivable physical law manifests somewhere in the eternal cosmic foam. We are left gazing into the abyss of possibilities, wondering if our reality is just one fragile bubble in an eternal frothing sea of universes, a single note in a symphony that never ends. This is not destruction. It is replacement. The very fabric of reality rewoven as it passes. A silent, instant rewriting of everything. We are alone. And yet we are not alone. We are one among infinite reflections in a broken cosmic mirror.
The ultimate frontier of physics, where quantum fields meet space-time itself, a fundamental tension emerges. The Planck scale 10 to the 19th gigaelectron volts here. Gravity is no longer a background stage, it is an active player, distorting the very rules of reality. In the quantum vacuum, a false vacuum is not a true emptiness, it is a temporary state of tranquility, a locally stable configuration hiding a lower energy reality it can tunnel shatter into nothingness. But gravity changes the equation. It warps the geometry of decay. A bubble of true vacuum attempting to nucleate finds its expansion suffocated. The negative energy density within it fights against the surface tension holding it together. The ratio collapses. The decay fails. This is stabilization by distortion. And at these unimaginable energies, the constants themselves begin to run. The coupling between the Higgs field and the curvature of space-time becomes critical, represented by a single parameter. When Chegs is not zero, the field is tethered to the geometry around it. During the violent birth of the universe, inflation reheating, this non-minimal coupling acts as an anchor. It counters the metastability woven into the standard model by the precise masses of the Higgs and the top quark. It prevents a catastrophic rewrite of physics in our cosmic infancy. Consider transitions from a de Sitter universe expanding positive energy to an anti-de Sitter universe. A negative energy sink. Gravity suppresses this decay. It favors our cosmological reality over a terminal crunch into oblivion. But quantum gravity is not merely a stabilizer. It introduces its own deeper rules. Models like gravitational Poissonian spontaneous localization, GPSL, propose a fundamental graininess to reality. Instead of smooth, continuous evolution, mass densities undergo stochastic, spontaneous collapses. These discrete flashes of existence prevent the slow drift into instability that a continuous quantum field might allow. It ensures stability through interruption. Here lies the ultimate paradox. Classical gravity, the warping of space-time, tends to stabilize our precarious vacuum, yet a complete theory of quantum gravity, string theory loop quantum gravity, may reveal instabilities we cannot yet see, phenomena absent from the flat space calculations of quantum field theory. The Higgs potential in curved space-time is not a static landscape. It is a dynamic warping terrain. Valleys of true and false vacuum shift and deepen under the immense weight of cosmic curvature. What we perceive as stable may be an artifact of an incomplete picture. A temporary calm in the storm of Planck scale physics. Gravity giveth, and quantum gravity may take the way.
The search for a final theory is, at its heart, a search for the true nature of nothingness. Is our vacuum eternally secure, or is its stability a fragile, temporary gift from the geometry of the universe itself? The answer lies beyond the Planck threshold, in a realm where space-time and quantum fields are finally unified. Or perhaps, finally shattered.
The promise of ultimate unification shatters, fractures into a revelation so vast it collapses everything we hope to find. String theory does not give us one universe. It gives us a landscape of possible realities. Each one, a complete cosmos with its own laws, its own particles, its own destiny. This is not just multiplicity. This is cosmic vertigo.
The mathematical heart of string theory, the Calabi-Yau manifolds, twists and folds intricate shapes with hidden dimensions wrapped in quantum fluxes. Through flux compactifications, through the KKLT mechanism, these shapes stabilize and do it. Each configuration a different vacuum state, a different reality waiting to be born. Our universe is not fundamental. It is not special. It is merely selected one bubble among infinite others in an eternal ocean of inflation. This solves the great mystery, the cosmological constant problem. Why is our vacuum energy so unnaturally small? So precisely tuned for life, because we are here to ask the question. The anthropic principle in a landscape of vacuum, most are barren, lethal. Only a vanishing few can support complexity. Only a vanishing few can give rise to us. We don't live in a special universe. We live in a survivable one. Supersymmetry, the elegant symmetry that promised to solve so much, dilutes across this cosmic terrain. Once hoped to provide unique predictions, it now fractures, breaks at different scales and different vacua. The weak scale supersymmetry we search for at the LHC. Not a fundamental prediction, a statistical fluke, just one possible value among countless others. Supersymmetry breaking becomes not a certainty, but a possibility. The dream of a single equation, a single reality, collapses. String theory transforms from a theory of everything to a theory of anything. Prediction gives way to selection, physics gives way to statistics. Eternal inflation becomes the engine of this multiplicity. Quantum fluctuations spawn bubble universes endlessly. Each bubble carries a different vacuum state, a different set of physical laws. We inhabit one such bubble, our observable universe, a tiny pocket in an infinite foam of cosmic possibilities. Critics see this as surrender, the loss of predictive power, the end of fundamental explanation. Proponents see it as inevitable, the only solution to fine-tuning problems that have haunted physics for decades, the only framework that makes sense of our improbable existence. The landscape is not destruction, it is revelation. A truth more unsettling than we imagined. We are not at the center of creation. We are not the inevitable product of elegant equations. We are a statistical accident, a rare configuration in an ocean of dead possibilities. Our laws are not written in stone, they are written in probability. And somewhere in the vastness of another bubble holds different laws, different particles, different life, or no life at all. The landscape does not answer our questions. It redefines them. We are left not with certainty, but with multiplicity. not with prediction, but with selection. The universe is not what we hoped it is, what it had to be, for us to be here, to wonder.
Our existence is not neutral. We are not passive witnesses to the cosmos. We are caught in a profound bias, a systematic distortion that colors everything we see. In 1974, Brandon Carter shattered the illusion of objective observation. He introduced a revolutionary concept, an anthropic principle. We must consider our own existence as observers when evaluating cosmic probabilities. We only see what allows our seeing, like catching only large fish with a coarse net. We sample reality through the filter of our own existence. This bias manifests in shocking precision. Consider the vacuum energy density. The cosmological constant lit, it appears fine-tuned to 1 part in 10^20, a number so vast it defies comprehension. If this value differed by even the slightest margin, the universe would have collapsed immediately into nothingness, or expanded too violently for any structure to form. No stars, no planets, no us. John Barrow and Frank Tipler expanded these ideas into a comprehensive framework. Nick Bostrom formalized the statistical paradoxes through concepts like the self-sampling assumption. This reasoning leads to startling, unsettling conclusions. The doomsday argument suggests we are statistically likely near our extinction point. Humanity stands at the edge of an abyss according to pure probability. We live in an anthropic shadow, blind to the catastrophic events that could have eliminated us before we began observing. This fine-tuning presents a fundamental dilemma. Does it imply a cosmic designer? Or does it simply reflect our observer bias in a multiverse where every possible universe exists? The multiverse hypothesis attempts to solve the problem. If infinite universes exist with different physical constants, we inevitably find ourselves in one that permits life. But this merely shifts the mystery. Why this particular set of universes? Why these fundamental laws governing the multiverse itself? We enter a recursive paradox, an infinite hall of mirrors. Every attempt at rational explanation creates new, deeper mysteries. The multiverse hypothesis doesn't solve fine-tuning. It dissolves it into an ocean of infinite possibilities. Scientific explanation itself seems threatened. If every possible universe exists somewhere, then our laws become mere local bylaws in an infinite cosmic bureaucracy. There is no why, only infinite what-ifs. We are trapped observers in a universe that allows observation. But this very fact biases everything we measure. Everything we deduce, the cosmic truths we seek may be forever inaccessible, filtered through the narrow window of our own existence. The fine-tuning remains 1 part in 10^20, a number that either points to profound design or to our inevitable observation of a survivable universe among infinite dead ones. Either way, we are left with cosmic vertigo. A universe that seems impossibly tailored for life, or observers who inevitably find themselves in the vanishingly small fraction of reality that permits observation. This is not just physics, it is metaphysics. The boundary between scientific explanation and spalescent and philosophical mystery has collapsed. We peered into the abyss of our own existence, and the abyss peers back through the distorted lens of our observation.
The vacuum of space is not empty. It seethes with energy, a relentless invisible ocean of quantum fluctuations. This is vacuum energy, and according to our best theories, it should be catastrophically large. A cosmic force so powerful it would tear the universe apart in an instant. Yet when we look out at the cosmos, we see something else entirely. The cosmological constant, Einstein's greatest blunder, is real. But its value is staggeringly small. A discrepancy of 120 orders of magnitude, the most glaring mismatch in all of physics, a problem that defied solution for decades. In 1987, physicist Steven Weinberg approached this problem from a radically different angle. He asked not why the constant is so small, but what values would allow us to be here, to ask the question anthropic reasoning. If the cosmological constant were too large and positive, the universe would expand too rapidly for galaxies to form, stars would never ignite, planets would never coalesce. Too large and negative, space would collapse in on itself before life could emerge. Only a narrow window permits observers. Weinberg calculated this window. He predicted that the cosmological constant's energy density should be roughly 5 to 100 times the matter density of the universe. A bold forecast made when dark energy was still a theoretical phantom. For over a decade, this prediction hung in the void, a speculative idea awaiting observational verdict. Then, in 1998, the verdict arrived. Two teams of astronomers made a shocking discovery. Distant supernovae revealed that the expansion of the universe is accelerating, driven by an unseen force, dark energy. The cosmological constant had been detected. The measurements were precise. Dark energy constitutes about 70% of the universe's total energy density matter. About 25% the ratio, approximately 2.8 times, not 5, not 100, but squarely within Weinberg's predicted range. The theoretical ghost had found its physical form. Weinberg's anthropic prediction, born from pure reasoning, had been spectacularly confirmed. The vacuum energy, it seemed, was not randomly set. It was constrained by the very possibility of our existence. This revelation reshapes our understanding of the vacuum state's evolution. The cosmological constant may not be a true constant, but a value selected from a landscape of possibilities. Universes with inhospitable vacuum energies vanish into oblivion. Only those with the right values give rise to galaxies, stars, planets, and observers. We are not mere bystanders in the cosmos. Our presence is written into the fabric of reality. The vacuum energy, the cosmological constant, the very expansion of space, all bear the imprint of our possible existence. The universe is not just something we observe. It is something that, in a very real sense, observes us back. What does this mean for the nature of reality? That some fundamental constants may not be fixed by deeper physical laws, but by the simple requirement that the universe must be capable of supporting observers like us. The cosmic vacuum whispers our name. Consider this chilling possibility. At any moment, the universe could simply cease. Not with fire nor ice, but with silent mathematical inevitability. Our cosmos exists in a false vacuum, a metastable state, perched precariously above a deeper, more fundamental reality. A state of temporary stability, waiting to collapse.
A single quantum fluctuation could pierce this delicate balance, triggering a cascade that rewrites reality itself. Quantum tunneling through an energy barrier, a process described by the Coleman formalism. The bounce action of the Higgs field calculating the precise trajectory through potential energy landscapes. A true vacuum bubble, nucleating in the fabric of space-time. It expands at light speed, rewriting the laws of physics as it passes, erasing all structure, all matter, all memory. The ultimate cosmic eraser. Yet, the numbers, the probability calculations yield a decay rate of per unit volume a number. So small it defies comprehension. A decimal point followed by 307 zeros. Then a one statistical analysis translates this cosmic fragility into timescales. With 95% confidence, years. A timescale that makes the current age of the cosmos, 13.8 billion years, seem like the briefest spark in an eternal night. But the estimates grow more staggering still. Refined analyses place the expected lifetime at years. 1, followed by 7 hiding zeros, numbers that stretch beyond imagination. Expert surveys reveal a 45 fixed 6% probability that our vacuum is indeed metastable. So the possibility is real, the mechanism understood, the Higgs field's quartic coupling running negative at energies around G. The very mathematics of our universe suggests this instability. Yet the safety margin is cosmic gravity suppresses decay. In some cosmological backgrounds completely stabilizes the false vacuum. Even cosmic inflation, even reheating, cannot significantly elevate the risk. Here lies the profound paradox. The universe appears fragile, perched on a knife's edge, yet statistically, it is nearly immortal. A dance of mathematical dread and statistical serenity. The false vacuum could decay at any moment, but any moment spans eons beyond imagination. This is not a countdown to doom. It is a measurement of stability, a calculation of cosmic resilience. These numbers are not predictions of when, but demonstrations of how improbable. The universe whispers a number, and in that number we find both warning and wonder. A reminder that our existence balances on quantum probabilities. Yet those same probabilities grant us near eternity. The vacuum decay calculations stand as one of physics' most profound achievements. They measure not just risk, but the staggering timescales on which reality itself operates. In the tension between catastrophic possibility and statistical near certainty, we glimpse the true nature of our cosmic home. A place both terrifyingly fragile and unimaginably enduring.
reality hangs, suspended by the thinnest of quantum threads, perched on a precarious ridge in the cosmic landscape. A false vacuum state. The mathematics whisper a sobering truth: we exist on borrowed time, our metastable reality projected to last perhaps years, or end in the very next instant. Then comes bubble nucleation, a microscopic flaw in the fabric of space-time. Quantum tunneling pierces the veil, birthing a sphere of true vacuum. It must reach a critical radius, the tension divided by the energy difference. If it crosses this threshold, the universe begins to rewrite its own rules. It expands at 0.95 times the speed of light. A wall of new physics surges outward ahead, oblivion behind. A universe erased. This is not destruction, it is replacement inside that expanding sphere. The Higgs field's vacuum expectation value shifts. The fundamental constants, particle masses, force strength, are rewritten instantly. Consider the forces sculpting our cosmos: gravity, electromagnetism, the nuclear forces inside the bubble. They may unify or cease functioning entirely. Particles transform into massless phantoms or ultramassive anomalies. Atoms shatter. Gravity overwhelms. Electromagnetic repulsion, crushing matter into unrecognizable forms. Chemistry evaporates. Structure dissolves. But from this cataclysm, a daughter cosmos is born, causally disconnected from its parent. This new realm undergoes its own inflation, spawning stars and perhaps life governed by entirely different laws. Imagine a universe where light is slower, gravity is repulsive, or time flows backward. These are mathematical possibilities in the post-decay landscape. Our cosmos may be just one fragile bubble in a multiverse foam, countless realms with radically different rulebooks. The standard model suggests our electroweak vacuum is metastable. Theories like supersymmetry might stabilize it, but the possibility lurks in the quantum foam, a silent rewriting waiting to happen. We are temporary. Our physics is not fundamental. It is contingent, one arrangement among infinite possibilities. The universe we know could be replaced in an instant, without warning. And what then? New universes, new laws, new observers unaware their reality was born from the death of ours. This is the ultimate fragility, not just of stars, but of physics itself. We are passengers in a cosmos that could, at any moment, decide to play by an entirely different set of rules.